So, good morning, everyone. Thanks for joining this presentation about offshore testing and how this test can support future commercial projects. My name is Laura-Mae MACADRE. I'm project manager at OpenSea Foundation, and in particular for the SEMREV test site. And before I start, I would like really to highlight that this presentation was a real team effort. I would like really to thank my colleagues from OpenSea and partners from Valeco, Ifremer, EDF, and BDI, who provided content and inputs to make this presentation happen. So let's have a look at the agenda. I will start with a very brief introduction about OpenSea Foundation. Then I will explain what is the role of the offshore test sites, who are the actors involved in offshore testing, and then we will focus on 5 key examples about these stakeholders. So OpenSea Foundation is a newly created research infrastructure gathering the 5 different test sites in France for marine renewables, so Paimpol-Bréhat, Sainte-Anne-du-Port-Zic, SEMREV, Cineo, and Mistral. Our role is to coordinate the tests done on these test sites, but also to develop, to create new test infrastructures according to the needs of the sector, and in particular for floating wind turbines of higher power, for instance, 15 to 20 megawatts. So the different test sites have complementary resources, and you can test on the test sites tidal turbines, floating wind, wave energy, floating solar, but also hydrogen production. But you may wonder, what is the test site and what is our role? So the first mission for us is to enable testing at sea of offshore renewable prototypes in a dedicated area. And this area is secured, navigation is restricted. This area is fully permitted. We get all the authorization to conduct the test, and this area is often grid connected. Secondly, we provide an experimental platform for the whole sector to increase skills and to cut risk and cut costs for the future development of offshore renewables. Then for each prototype tested on the test, we do environmental impact assessment. So we will really characterize the impact, we will assess the environmental impact of the prototype. And finally, we have a strong role to play in terms of communication, dissemination, scientific mediation, and I will speak again about this later in the presentation. So here you can see nice pictures of all the prototypes that have been tested on the OpenSea Foundation test sites, or for some of them that are still tested now. So you can see floating wind at Sainte-Anne-du-Port-Zic and SEMREV. You can see tidal turbines at Cineo and Paimpol-Bréhat. And you can see wave energy converters again at Sainte-Anne-du-Port-Zic and SEMREV. So obviously during these tests, the technology developers will collect a lot of data, will increase knowledge about their technology, and they are the first beneficiary of this test. But there are many other stakeholders involved in offshore testing, and they will also benefit from the test. Do you have any idea who are these other stakeholders involved in offshore testing, who will contribute or who will get something from the test? Maybe we can try to list them together. So obviously I mentioned technology developer, but at early stages of the project, we can also think about project developers, consultancies, like engineering consultancies, but also environmental consultancies, but also bankers, insurers. And at more operational stages, we can think about manufacturers for the prototypes, port infrastructures, the marine contractors, in particular for the installation of the prototype, and also the maintenance operators during the exploitation phase. On a more transverse aspect, other stakeholders are involved, like regulators, certification bodies, but also on the safety side, public authorities, etc. So as you can see, there is a whole ecosystem of stakeholders involved in offshore testing activities. And now I will focus on 5 key examples of stakeholders and illustrate how they contribute and benefit from the test. So my first example is about site characterization. For each site, for each of the test sites, we collect a lot of data at sea, and we collect them and make them accessible independently from the prototype testing. So let's take the example of Sainte-Anne-du-Port-Zic first. This test site has been instrumented for more than 20 years. They have started offshore measurements, and currently they are still measuring wind, wave, current, and a lot of physico-chemical parameters. Now let's take the example of this buoy that you can see here. It's a Marais-Liroise buoy that is on the site, and it will monitor at high frequency, so every 20 minutes, a number of physical-chemical parameters like temperature, turbidity, conductivity, etc. And in addition to this, there are frequent samplings on the site. So every 2 weeks, there are samples made to monitor these same physico-chemical parameters as part of the SOMLIT project. So all this data collected, then we make them accessible to the whole community. And I put you some links here, so if you want to check and have a look, it's available for the whole sector. And it will benefit, for instance, engineering, but also offshore operations, or simply, more generally, climate science. Same philosophy at SEMREV. We are monitoring the test site for more than 10 years now. We are monitoring wind, wave, current, tides, and marine growth. We collect all this data. We put them in a public report called the MACADRE Design Basis that we published last year. So again, you can access it on internet. And you can also access our live data. So if you want to know what's the wind in Le-Croisic now, you just go on the website and you can have an idea. At Mistral also, a lot of measurements have been made. A lot of measurements have been made in the past by Valeco, in particular for metocean, for geophysics. They even put a LiDAR onshore. And currently there are 2 monitoring buoys on the test site as part of France Energy Marine Research projects. So the Memo Flow buoy is more focused on wind and wave monitoring, and the Monabiop buoy will be more for marine growth monitoring. For the future, we will continue to monitor the site and to collect all the necessary data in order to have all the data needed for a floating wind turbine to come on the site. Now my second example is about marine operations. So when do you think we do marine operations on a test site? So obviously when a prototype is being installed, but also when we upgrade our own infrastructure. And here you can see a very nice movie of the installation of 2 new cables at SEMREV, and this happened 2 months ago. But also on a more regular basis, when we deploy or when we retrieve instrumentation, we have also marine operations. These operations are very challenging on our test sites because quite often it's the first time for the marine contractor. Maybe not the first time, but one of the first times in an offshore renewable context. It's also very challenging because they work in unusual conditions, in very harsh environment. Let me remember you that we are putting prototypes in the water where we have the worst waves, the worst currents, the worst winds, because this is where the resource is to produce electricity. But then for marine operations, it's very challenging. And finally, all the operations on our test site are quite unique. They are like a one-of-a-kind. It's not like a commercial farm of floating wind turbines or fixed wind turbines where you will install 100 wind turbines. You might be slow at the beginning, but then getting quicker and better. Here, they will install like 1 prototype or 1 or 2 cables, and they need to be good at the first time. So all these challenges, we face them together with the marine contractors, and we had the chance to work with a number of marine contractors on the different test sites of OpenSea Foundation. And in the end, we gained experience together. We used this test site as a playground, and this will help the future marine operations for commercial projects. So I could not resist and put you more pictures of marine operations on the different test sites, thanks to my colleagues from Paimpol and from Cineo. And here you can see a nice picture of an oceanographic instrumentation deployed on the test site. Paimpol is a tidal test site, so with the current it's very challenging. You can see also in the middle 2 nautical means, huge nautical means to install tidal turbines, and these were first experiences in France. And on the right side you can see a diver. So yes, there are divers on a tidal test site, and you can imagine the challenge associated with it, but with the right weather conditions it's possible. Here again, together we use the test site as a playground, and we learn together for these operations. And same philosophy at Cineo. You can see the pictures of the operations on the cable, on the signaling buoy. And here at Seanergy, the challenges are obviously against the current, but also the total lack of visibility under the water. There is high turbidity, but also as it is a river, the high debris in the water, like tree trunks. So yeah, unexpected challenges, but we learn together on the test sites. So I move on to the third example. I will now speak about environmental impact assessment that we do at SEMRE for more than 10 years. For each prototype hosted on the site, we characterize the impact, the environmental impact of the prototype, because it's mandatory. It's part of our authorization. And this is what you see in red on the slide. So we monitor underwater acoustics, electromagnetic fields, benthic communities, for instance. In addition to that, we also monitor complementary, complementary monitoring, for instance, on birds and bats, on marine mammals, because it's relevant for our specific site, and we develop research projects on these topics. As for site characterization, we put all of this in a public report that you can download on the internet, and we published the FlowGen Environmental Impact Assessment, who said after 3 years of operation of the prototype, there is no significant impact observed on the test site. Again, on Mistral, a lot has been done on the environmental part. They have monitored for the baseline, and some of the monitoring are still ongoing. For instance, on birds, bats, marine mammals, but also on the physics, like water quality, underwater acoustics, etc. And here the idea is really to collect a lot of data in order to increase knowledge, to share them through research projects, and in the end, to improve conservation of specific local species. So all this work, beyond the technology developers, they can benefit also the environmental associations, they can benefit the public organization, like nature parks. Okay, now let's move on to a different type of stakeholders, and let's speak about safety. We used the FlowGen prototype developed by BW Ideal to organize the first evacuation exercise from a wind turbine in France in 2022, last year. So we simulated an injured person on the prototype, and this person was evacuated through boat and through an helicopter that you can see on the movie. And the idea was really for the safety stakeholders like CROSS, SNSM, to train and make sure that their protocol is adapted for floating wind turbines in France. So yeah, it was really a close cooperation with the different stakeholders, and here you can see the guy is safe, and he will say hello and come back home. Okay, just to finish on communication and scientific mediation, we tried to make sure that this test at sea also benefits the general public, that the general public will get something from the prototype at sea. So we organize a lot of events for the general public. We explain what are offshore renewables. We answer their questions. We hear their concerns. We organize these events onshore, but we also take them offshore. We bring them on a boat, and we show them for real what is a floating wind turbine or a wave energy device. We try also to make these events fun and accessible. So for instance, on the bottom left picture, you can see we organized a game. So we sometimes wear red hats, but no comments about this. And we also try to target different audience. So on the bottom right picture, you can see a nice event in Marseille called Les Ailes de l'Océan, where the event targeted girls in high school to show them what are the offshore renewables jobs. I will conclude my speech with these takeaways. So the tests at sea will reduce risk for the whole sector. Obviously for the technology developer, but not only. I also mentioned marine operators, environmental associations, safety stakeholders, the general public. The test site is really a kind of playground for all this ecosystem to do the first times in an offshore energy environment and to gain experience before going to commercial projects. And just an open up here, we mentioned testing of like a full prototype connected at sea, etc. But testing at sea can also be for a single component or even just for materials, like on coupons. It can be on sensors, on tools, on inspection methods. So if you have anything you would like to test at sea, we have 5 nice test sites, and don't hesitate to come and present your ideas. So now I can take some questions if you have some. And otherwise, don't hesitate. Feel free to come on our booth, OpenSea booth on C18, or you can send me an email after the presentation. Thank you very much.
Mm-hmm.